Okay. Complex zeros and the fundamental theorem of algebra is our topic today. Complex zeros. We learned complex numbers last year in Algebra 2 for the first time. Do you remember anything about what complex numbers are? Well, you learned them last year. Are you supposed to remember it? Technically, yes, you should remember what you're taught. However, you know. Complex numbers? Okay. What if I say imaginary?
Oh,
yeah, I know.
Just thinking of it like imaginary.
Is it the same thing?
Mm-hmm.
Oh,
yeah.
I know what it is.
So you guys learned imaginary numbers last year, and I can guarantee that I threw the word complex numbers out there. Okay, because when we talk imaginary, you guys are thinking I, yes?
Yeah.
But when we gave that form, we usually didn't just say it was like 2i, but remember we usually had the a plus bi form, where it was a real part plus an imaginary part. That's the complex number. When you have it all together and it's that a plus bi form, that's your complex number. So we are going into dealing with complex numbers. I've kind of already hinted that we are going this way. When we've talked about some of these other problems, and like say it's a degree 4 problem. And I said, okay, so there are at most 4 like x-intercepts, right? 4 places we can see it crossing. However, are there actually all 4 places crossing? And no, there's sometimes where, okay, it's an x to the 4th power, but there's only 2 answers. Well, that's because the other 2 are complex numbers, or in other words, they involve imaginary numbers. And that's the direction we're going today. So, graphing calculators, I may show you a little on the graphing calculator. I don't necessarily know that you have to have yours out, though. You can if you want. So first of all, fundamental theorem of algebra. A polynomial function of degree n has n complex zeros. So, in other words, if it's degree 4, there are 4 complex zeros. We're no longer saying at most 4. We're saying there are 4. Now, keep in mind, a complex zero, it can include the imaginary, but it can also include just the plain old real, because if it's a plus bi, you could have some number a plus 0i, where there's no imaginary part. So the point is today, in these problems, it's degree n. If it's power of n, then there are that many zeros or solutions.
So when you say there's 4 complex numbers, those aren't all imaginary.
They don't have to, right. A complex number, we often think of it being imaginary, but it's that a plus bi form. So the a part could be the only part that exists, and the bi part is a 0i, so that doesn't matter. Okay. Some of these zeros may have a multiplicity greater than 1, and that's just the idea that, you know, if it's power 4, but there's only 3 answers, well, maybe one of those answers had a squared on it, and so it repeated. Linear factorization theorem. Given the function f of x of degree n, so something greater than 0, then f of x has precisely n linear factors. Again, going back to, we are going to be including the imaginaries today. So power of n factors. Complex conjugate zeros theorem. Given function f of x with real coefficients, if a plus bi is a 0 of f of x, then so is its conjugate. So we will talk about this when we get to a certain point, but complex conjugate zeros. If a plus bi is a 0, then so is a minus bi. The idea that these imaginary roots always occur in pairs. Similar to the idea, remember how I kept saying the irrational roots always occurred in pairs? Like if you had an answer of square root of 5, there was also the negative square root of 5, so it was plus or minus square root of 5. Same idea here with the imaginaries. Irrationals and imaginaries will always occur in pairs. Now, before we go into this, let's review. What is I?
Negative square root of negative 1. I can't. Ooh. I've been so frustrated today. I can't talk.
Okay. I is square root of negative 1. Are we there? Does that sound familiar? If I is the square root of negative 1, What is I squared?
1. It's just
Negative 1.
Oh.
Because what happens when you square a square root? You get whatever is under the square root, right? I know I've said that before.
Yeah.
Okay, so 2 key pieces you need to know going into this lesson, because we have to remember how to work with our imaginary units here. Let's look at example 1. Write the polynomial function in standard form. Do you guys remember what I mean by standard form?
Maybe ax squared plus bx.
Okay, so general idea of ax squared plus bx plus c, except it's just going in order from degree, right? The degree could be higher than x squared, but just going in order from highest degree to lowest degree. So we're going to write these in standard form. We're going to identify the zeros of the function and also the x-intercepts. And we'll talk about those, how those are alike and different when we get there. So let's look at A. Standard form. How do I get this to standard form? As we both have our mouths full of water. Okay, Chandler was making the motion there. We are foiling.
Yeah, that's it.
Okay,
Yeah.
so as we foil this out, first, and I'm going to foil this one the long way for a moment, x times x squared. What's my outsides? My outsides are x times 2i, so I'm going to say plus 2ix. Insides, minus 2ix. And last, negative 2i times plus 2i. Minus 4i squared. Now, I said I was doing it the long way this time. I'm not going to necessarily keep writing all this out because what's happening here?
In the middle.
Okay, yeah, my middle's canceled. I don't know if you guys are realizing we multiplied conjugates. Anytime you're multiplying conjugates, the middles are designed to cancel. So I have remaining in
X squared.
x squared. What do we know about minus 4i squared, though?
It's negative 4 times negative.
Yeah. I squared is negative 1. So negative 4 times negative 1 makes this a plus 4. So our standard form is f of x equals x squared plus 4. Always remember when you see that I squared, basically drop the I squared and change the sign of the problem. Questions on standard form here? Okay. The next part says to identify the zeros. How do we find zeros of a problem? What? Okay, we can graph it. I'm not going to graph this one though. Okay, set things equal to 0 algebraically. Now, and easiest, rather than setting our end result equal to 0, we go back and set my factors equal to 0. Okay, easiest place is to set our factors equal to 0. So I'm going to set x minus 2i equals 0 and x plus 2i equals 0. Solve those, and what are my zeros? A positive 2i and a negative 2i. I'm going to write 2i, comma, negative 2i. You are welcome to write plus or minus 2i if you want. You'll see me do that some. And what were these? These were my zeros. Okay, these are my solutions then. Now, we have one more question if you look up there. And that is, what are the x-intercepts? Okay, so generally speaking, it's normally our zeros. Can you graph 2i for me, please?
No. It's imaginary.
Okay. So on a typical xy axis, is there a place to graph 2i? No, not on your normal real axes, right? And so what are my x-intercepts in this problem? But do we know the square root? The square root of -1 takes us back to I.
But then,
Well, -1 be that you already plugged in.
But it's imagined. Square root of -1 is defined as an imaginary unit. So what's going to happen is, we're not going to see this on the graph.
we can just imagine it then.
You can imagine all you want, but it's not going to actually touch the x-axis. Okay? Let me take a different direction with this, because I don't think you guys want to believe where I'm going. Standard form, this multiplied out to be x squared plus 4, yes? Can you visualize? And I can put it on the calculator if you want. X squared plus 4?
Yeah.
What is that? Parabola?
Over
Up 4. If I take a parabola and move it up 4, where does that touch the x-axis? It doesn't. Okay? So the idea that I'm trying to get you guys to believe is that because these zeros are imaginary, there are no x-intercepts. So, no x-intercepts, and I'll even write myself a note out here, because zeros are imaginary. Okay. If I graph that standard form, I can't graph x minus 2i times x plus 2i. I don't have a way to type in an I on the graph, or on my equation, okay? And just typing in the letter I is not the same. Notice, there's my parabola, moved up 4, not touching. So, generally speaking, are zeros and x-intercepts the same thing? As long as we're talking real numbers, okay? If you have imaginary zeros, though, those are different than x-intercepts. So, I know a lot of times, I'm guilty, I say, okay, these are pretty much the same, but this is one of those places we have a slight difference. Questions on that one? You believe me now, whether you like it or not? You guys were a little harder to convince in my morning class. That's good, though. You're questioning it. Okay. B. F of x equals x minus 3 times x minus 3 times x minus radical 2i times x plus radical 2i.
I'm not sure I want to do this one.
So first of all, there's a note here. And notice it says, notice x minus 3 has a multiplicity of 2. Do you guys remember what happens with a multiplicity of 2?
It touches, it doesn't cross, it touches.
Yeah, so it's still going to be a 0 because it's going to come down and touch at the x at 2, or excuse me, at 3, but it's not actually going to cross. So it still counts as a 0, it just touches instead of crosses. And that will represent 2 of our 4 answers. Now, first thing is to go for standard form. What's my plan need to be if we're going for standard form here?
Can you FOIL the first two and FOIL the last two?
Okay, yep. Foil them in pairs and then foil them together. Now, one thing I always say, if you have conjugates, foil those together first, or you'll make your life a lot more difficult. Meaning, these two at the end are conjugates of each other, right? And specifically, they're conjugates with the imaginary. You must foil these together first, okay, before foiling them with anything else. And while we're at it, yep, let's do the x minus 3. So, x minus 3 times x minus 3, what do we got?
X squared plus 9.
Check again. They're not conjugates. Okay, so it's x squared minus 3x, which makes it minus 6x plus 9. Yeah, beware, those signs are not opposites, so we do have to actually add that. Next step. X times x, x squared. What do you notice happening? X times radical 2i and x times negative radical 2i.
We're gonna cancel.
They're going to cancel. Do I have to write them out?
No.
No. I did on the last one kind of as a starter problem. If you want to write them out, that's fine, but these truly are conjugates. So you don't have to write them out. Let's jump to the end. Negative radical 2i times positive radical 2i. Almost.
Is a negative 2y squared.
You guys see where it's going. Let me write it out. So just so I want a visual here for people. Negative times positive is a...
Wouldn't it be positive 2?
Okay, let me step it, but you guys are getting there. Negative times positive is a
Negative.
negative.
I thought that I was.
Nope, I is not, and I don't think you'll ever see the I under the radical. Okay, there's the difference. Radical 2 times radical 2. 2. You can say it's square root of 4, but it reduces to 2 again. I times I. I squared. What do we know about I squared?
Negative 1.
Negative 1, so negative 2i squared becomes plus 2. Are we okay with that now? Yeah. As I said, you guys are getting there, but I still wanted to write it out and make sure that we all see it. Now what? Multiply again, right? Notice, because these i's were involved in conjugates, my i's are gone now. And that's why I said multiply those conjugates first, because it will eliminate your i's. I don't care officially how you multiply these. Personally, for me, what I find easiest is I take my binomial and take turns multiplying it in. So like I like to take the x squared from the binomial and multiply it by everything in the trinomial. So that's going to become x to the 4th minus 6x cubed plus 9x squared. And then I'm going to take the 2 from the binomial and multiply it by everything in the trinomial. So plus 2x squared minus 12x plus 18. Final step is to clean it up. I see x to the 4th, still minus 6x cubed, plus 11x squared, minus 12x plus 18. That is my standard form. Zeros. How do I find my zeros? Yes, each of your factors equal to 0. X minus 3 equals 0. X minus 3 equals 0. X minus radical 2i equals 0. X plus radical 2i equals 0. If that's the case, what are my zeros?
Positive 3 and plus minus radical 2i.
Okay. Positive 3 and plus minus radical 2i. Okay, so no, you don't have to state the 3 twice. And yes, you can do plus or minus radical 2i. Those are my
0.
zeros. Last part is x-intercepts. What are you thinking about x-intercepts? 3, because it is a real number. Okay, plus or minus 2 radical or square root of 2i. It's an I. You're not going to be able to see it. So x-intercept is just 3. if you want to think of it as kind of a check, you can. I can type this into my calculator. Now, I can't type my original set in because I can't type i's in, which means I'm typing out my multiplied part. My standard form. So if I type my standard form, which is what I just did here, okay, first of all, it's kind of checking the multiplying because we know that there should just be one x-intercept at 3. And when you graph this, notice, what do I have? Touching at 3. Did we already talk about touching? Should it be touching at 3? Yeah, because there was a multiplicity of 2 on that x minus 3. Okay, so that's kind of a check that I feel like, okay, well, maybe my standard form is right because it's doing what I expect it to do. Okay. Questions on that section? Okay, let's try one more then. As you read this next problem, it should seem familiar. Write a polynomial function of minimum degree. Okay, minimum's a little different, but polynomial function of minimum degree in standard form with real coefficients whose zeros include -3, 4, and 2 minus I. We've done this the last 2 lessons, technically. Okay. So does this sound familiar, guys? Are you guys with me still? Some of you are starting to zone off. Come back with me. F of x equals, okay. Normally it says polynomial function of, say, like degree 4. And then we know exactly what we're doing, or degree 3. This just says minimum degree, which you'll understand here in a moment why they do that. Standard form says we're going to have to multiply it out. So, the 0 of -3 is represented by the factor x plus 3. A 0 of 4 is represented by the factor x minus 4. A 0 of 2 minus I. This is where I'm going to kind of pause and say, yeah, something like that.
-2 minus I.
Not exactly. Okay. So, first of all, keep in mind, how did we get x plus 3? Technically, that is doing x minus -3, right? How do we get x minus 4? That's doing x minus 4. For this first time through, I'm going to write it out as it's x minus, and then I'm going to put in parentheses, 2 minus I. Because it's still doing x minus whatever that 0 is. In this case, the 0 is 2 minus I. Now, what if you remove those parentheses, what is that really, that x minus the quantity 2 minus I? That's really x minus 2 plus I when you distribute that minus sign. Okay. As you get better at understanding this and seeing this, you don't have to write out this first set. That's me trying to make sure you see where all the signs come from. Okay. Anything else? Anything else that I mentioned earlier today? We are going to FOIL here in a moment. Not quite ready to FOIL though. Up top, did you guys see what I just started? Complex conjugate zeros theorem. Reread that. What did it say? Okay, we're short of 0 still. Complex conjugate zeros theorem says if A plus BI is a 0, then so is its conjugate. What's the trick here? Are they going to tell me both and say, here are your two zeros? No, you have to know that theorem. You have to know that if you see one that involves an imaginary, you have to do its conjugate. So, the one that this references here is 2 minus I. What is the conjugate of 2 minus I? 2 plus I. So we have to do the 2 plus I. The other reason they said a function of minimum degree. If they tell you minimum degree, they don't have to tell you, oh, this is actually going to be a 4th degree. Even though we only gave you 3 zeros, this is going to be a 4th degree problem. Okay? So, if I write it the long way first, it's x minus, and my new 0 is 2 plus I. So x minus the quantity, 2 plus I. If I remove those inside parentheses, it's x minus 2 minus I, because I'm distributing that minus. I'm going to just carry down my x plus 3 and my x minus 4. What form do they want this answer in? Standard form. So what are we doing? We're doing lots of FOILing, lots of multiplying out. Now, what am I going to say that's important? Okay. I don't care how you do this, technically. It'll just be a lot harder if you don't. These two need to be the first pair that multiply together. Now, if you're multiplying these two, at the same time, you can go ahead and do the two reals. But those imaginary conjugates need to be multiplied together first, not with other things.
So they're the same now, since one, I mean, does it change anything that you took away the parentheses?
Yeah, I had to change the sign. Because here I was distributing, it was x minus the 2 minus I. So when I distribute that minus, it's minus 2 plus I. Over here is x minus the quantity 2 plus I. So it becomes x minus 2 minus I. Okay, easier one first. X plus 3 times x minus 4. X squared plus 3x minus 4x, so minus x minus 12. Okay, we're multiplying trinomial times trinomial. 3 by 3 means I'm going to have 9 total. Be careful. You can do it however you want. I'm basically going to take x from the first and multiply it by everything in the second trinomial. So x times x is x squared minus 2x minus ix. Now I'm going to take negative 2 from the first and multiply it by everything in the second. Minus 2x plus 4 plus 2I. Then I'm going to take I times everything in the second. Plus ix minus 2I minus I squared. It is. It's not that it's a horribly difficult lesson. It's tedious, though. Okay, I'm going to keep my first trinomial. I'm not going to do any type more multiplying until I clean up that mess there at the right. So I'm going to keep x squared minus x minus 12. Okay, cleaning up. X squared, I believe, stays x squared. Minus 2x goes with minus 2x and is minus 4x. Minus ix cancels with plus ix. While I'm at that business, 2I cancels with minus 2I. I have a 4. And what do I know about minus I squared? Yeah, it's minus negative 1, which is plus 1. And 4 plus 1 is 5. Good news, all of my I's are gone. And now we're multiplying two trinomials again. Okay, I'm going to follow the same process. X squared from the first times everything in the second. X to the fourth minus 4x cubed plus 5x squared minus x from the first times everything in the second. Minus x cubed minus plus 4x squared. And then minus 5x. Not going to disagree. There's that part in there. Minus 12 times everything else. Minus 12x squared plus 48x minus 60. Barring I made no mistakes that no one called me out on, we finish it up now. X to the fourth minus 4x cubed and minus x cubed minus 5x cubed. Wait. 5x squared and 4x squared is 9x squared minus 12x squared. 9 minus 12 is going to put me at minus 3x squared. Then I have a minus 5x plus 48x plus 43x minus 60. And my answer agrees with what I already have worked out, so we should be good here. Okay. Tedious is the name of the game, right? You have to be very careful. That is probably a good stopping point. Okay, I know in morning class we had several people absent, and so that gives me a chance on Monday to incorporate them. We will work to finish the notes on Monday, hopefully. We should. You know, I have to work over the weekend. Homework will be due Tuesday.